Yeah. So what is equation of a line in a space? So I told you, if you are trying to represent a line in a two-dimensional space, two-dimensional plane, it is very easy. What are the things we consider generally if you want to write an equation in a two-dimensional space, two-dimensional plane, sorry. So if you know the point through which the line goes through, and if you know another line, for example, parallel to that line, we know the slope from this line. So we'll substitute the same slope here, right? Yes or no? Something very similar approach is being used in understanding the equation of a line in a three-dimensional space. So what is that? Let's understand. So let us take a point A in a space. Okay, so let us take a vector A. So let us consider a vector, not a point, a vector A. Okay, which is joining the origin to A, like OA as shown in the figure. Okay, this is OA, vector A. And let us take a point P such that OP is represented by the letter R and AP becomes a vector which is parallel to vector B. Okay, so what we know here is the coordinates of P as x comma y comma z. Okay, so if this is the case, by triangular law of addition, we can see that OA plus OP, OA plus how it is. So it is OA plus AP, right? OA plus AP is equal to OP. So if I want to consider only AP, what I'm going to do is I'm going to write OP minus OA. So what is this OP? OP is represented by vector R, which is equal to, sorry, A is represented by vector A here. Can you see? Yeah. So what is OP? OP is a vector which is, let me rearrange all this. Yeah. So let us try to understand this first. There is a vector A, which is a position vector of point A. What is the position vector then? Which is starting from the origin. Okay. And let us have R, which is a position vector of P. Okay. Then AP be this vector which is parallel to vector B. So in that case, we can represent this AP as some constant with vector, some scalar, as it is just parallel. It may not be equal to B, but it may have a magnitude, a constant magnitude multiplied to that, right? So then from the triangular law of addition, this OA plus AP should be equal to OP. Yes or no? So that's what it is. OA plus AP is equal to OP. By the representation, we can say this is A, this is, what is it? Lambda into B, which is equal to OP, which is vector R. So this is how we use the equation of a vector in the three-dimensional space. So that means if I want to represent this vector, if I'm going to, I'll show you. See here, if vector R can be represented as vector A plus a scalar with a vector B, that is where it's parallel to, and the Cartesian planes, if A is a point, if the coordinates of A are x comma y comma z, and coordinates of P are x1 comma y1 comma z1, then what will happen is this entire vector can be written as vector R, which is representing x minus x1 I, right? So let's use this equation only. So if you are using this equation from the equation of this here. Equation of this can be written as A, which is, let's get back to the picture and convert the points exactly. So A is a point which is represented by A1, B1, and C1, and P can be represented by X1, Y1, Z1. So the vector OA can be represented as A1I plus B1J plus C1K. Okay, or we can simply say ABC. That's better. Then P can be represented as X1I plus Y1J plus Z1K. That we learned from the last class, right? So in that case, what happens to this equation? So what will happen to this equation is X1, yeah, X1I plus Y1J plus Z1K is equal to, we are going to have AI plus BJ plus CK plus lambda into what we have is EXI YJ plus ZK. This is how the equation is coming from. Okay, now we can remove that IJK which is common in all of them. So we can say X1 is equal to A plus lambda X. Then what is lambda now? What is A now? Lambda will be equal to what? X1 minus X by A, or we can also write X minus X1 by E. Similarly, same lambda will be equal to Y minus Y1 by B, which will be equal to Z minus Z1 by C. So that is how the equation of a line is coming. So this is the vector form of a equation, and this is the Cartesian form of an equation. Okay, so you can either use this. Suppose if you have 2 points in the line x1, y1, z1, and x2, y2, z2, then what happens is we can use not the direction ratio, we can directly use this format to find the equation. That is x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, which is also equal to z minus z1 by z2 minus z1. So this is the Cartesian equation of a straight line. Either you can use the direction ratios or you can use the coordinates of a 2 points. Okay, it depends upon what kind of information we have. Okay, if you have a direction ratio, we can use this formula. If you have both the points of a extreme points of a line segment or a vector with the directed line segment, we can use this. Okay, so let's see how we can use them in our questions by observing some solved examples. Shall we? Yes. So here we have this example. Let's see. So find the vector equation of a line that passes through the point with the position vector 2i, j, and 4k. So let's imagine this. So it's very important to imagine. Let's not just directly get into the formula. So let us first understand what they mean by this question. There is a position vector, means the point P with the origin. So that is a position vector. Okay, so that vector, let it be R. So that vector is given by what? 2i minus j plus 4k, right? In the direction that B. So that means we need to consider another direction, another vector B, which is of the form I plus j minus 2k. That means the required vector is, what is that? vector A plus lambda vector B. Am I right? So how do you do this? So vector A is given already. The vector A. So this is not the one. This we are finding out. Whereas the vector given position vector is here, not this one. It is A actually. So A is 2i minus j plus 4k. So in that case, if you want the equation of our vector, which is vector A plus lambda vector B. So what is the position vector they are given is 2i, right, minus j plus 4k, right, plus lambda times the given vector which is parallel to this ij and then minus 2k. So what happens to this is we end up with 2i, right, minus lambda I, yes, and this entire thing plus minus 1 plus 1 lambda j plus 4. What is the last one we have is minus 2 lambda. Okay, so this is how we get the equation. So this is what we can only stop at this point because it's only asking a vector format, and we can say lambda is a constant, an arbitrary scalar. We cannot find the value of lambda with the information they are given. Okay, so we can stop at this point only in that case. So let's go for the next question. What is the next question we have? The Cartesian form of an equation. What is the Cartesian form of an equation we have? We know Cartesian form is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Okay, so in that case, they are given 3 minus x by 5, which is equal to y plus 4 by 7, which is equal to 2x minus 6 by 4. It is z, I guess. It is z. Okay, so let's see how they have solved this question, and then we can apply that in our solutions. Okay, so it is 2z minus, yes, 6. So we want to first convert it to this form. That is, if I reverse it, what will happen is x minus 3 by minus 5, correct? So now it is 4 plus 5, but I want to convert it. That is y plus 4 is fine. Okay, by 7, but minus of minus 4. Can we write? Yes. Similarly, if you simplify this, 2 ones are 2 threes are, it will become z minus 3 by 2. So comparing this with the equation, we get a is equal to what? A is equal to minus 5, b is equal to plus 7, and c is equal to what? Plus 2. And x1, comma y1 and z1 are respectively equal to what? 3, comma minus 4, comma 3. Are we right? Yes. So what is the question? Write the vector equation of this line. So if you want to write the vector equation of this line, so we can say, so what we're going to do is we're going to have this as a point A, which is having the coordination 3 comma minus 4 comma 3. Then what will happen to our equation is vector A will become 3i minus 4j plus 3k. Okay, so whereas the given vector A will be ai plus bj plus ck. So the A we have got is minus 5i plus 7j plus 2k. Are we right? So that means our equation of the given vector is A plus lambda b. So if you want to write that, it is simply 3i minus 4j plus 3k. Yes, so we can observe this here directly instead of me writing here. Yes, so what do we have is 3i minus 4j plus 3k plus lambda times minus 5 minus j 7j plus 2k. So in general format, let me read it again. So if you want to write next time in the vector format, we always write as what is it? X1 I plus Y1 J plus Z1 K plus lambda times AI plus BJ plus CK. Okay, so what is this? It is actually vector R, that is position vector of a given vector, what we have to find out, plus A plus lambda B. And vector A is nothing but the position vector of a point representing x1 comma y1 comma z1. That is why this is what it is. Okay, so this is vector A. And vector B is represented by the direction ratios with the unit vectors. So the direction ratios which you find here, which will be useful to get the equation of the vector B. Okay, so let's look at the last question, solved example here in this, and then we can go to the questions. So what do we have? The direction cosines of the line. So what is our line? 4 minus x by 2 is equal to y by 6 is equal to 1 minus x by 3. We know by Cartesian format, if we have a direction cosines, the equation will be x minus x1 by a, y minus y1 by b is equal to what? Z minus z1 by c. By comparing, so if you want to rearrange this, it is x minus 4 by minus 2. Are we right? Yes. Y minus 0 by 6, which is equal to x minus 1 by minus 3. That means we have A as minus 2, B has 6, C has minus 3. So what is our question now? We have to find out direction cosines. What is direction cosine? L. So L is actually A by plus or minus root of A square plus B square plus C square. Can you recall that? So that is minus 2 divided by square root of what is this value? 2 square is 4 plus 36, 40 plus 9. So it is plus or minus 7. It's going to be minus 2 by 7 then. Right? Yes. It is actually, yeah, minus 2 by 7, and this will be 6 by 7, and the last one is minus 3 by 7. So that is our direction ratios. Okay, so you can observe carefully. So this is plus 2 by 7 and minus 6 by 7 and plus 3 by 7, because after rearranging, that's what we have got. Okay, so this is what the equation is. If we want to rearrange them, we have to get the positive values, means we can have x minus 4 by 2. Yeah, so all these values are going to give you direction cosines. Let's go for the next question, that is practice questions. We're going to solve them from our practice question section. Okay, yes. Yeah. So far, we have understood how to find the direction cosines with the given equation. Two forms of a line equation we have got to know, right? So one is Cartesian form, another one is vector form. Using that, so let's see. If a line has a direction ratios minus 8, that is, what is direction ratios? A is equal to, what is it? Minus 18. B is equal to what? 12, and C is equal to minus 4. Then what is the direction? What are the direction cosines? So L is equal to A by root of A square plus B square plus C square, which is minus 18 by, okay, so which is 18 square is 324. So let's solve this first. 324 plus 144 plus 16. What do we get here? 6, it's going to be 300 plus 100, 400, 400, 440. Yeah, so what we have is 300 plus 100, 400, 440 plus 44, which is actually 484. So 484, is it it is actually 4 into 121. If you take the square root, it is 2 into 11, which is 22. So our denominator is going to be plus or minus 22. Okay, so our L will be now minus 18 by 22, which is minus 9 by 11, and M is going to be 12 by 22, which is 6 by 11, and N is going to be minus 4 by 22, which is minus 2 by 11. These are our direction cosines. Okay, so what is the second question? Can you see? The second question is find the Cartesian equation of the line which passes through the point minus 2 comma 4 comma 5 and is parallel to this line. So our equation of B, okay, for that B, which can be written as A, I, it's a lengthy question, okay, but easy one. So I have to find A from this equation. So if you look at this x, okay, which is given as x plus 3 by 3, okay, y minus 4 by minus 5 is equal to y minus y1 by minus 5. So B can be written as simply, we also can see C as z minus of minus 8 by 6. So A is going to be 3. So given equation is 3i plus, equation of the line parallel to this will be 3i plus minus 5j plus 6k. Okay, so Cartesian equation of a line which passes through this minus 2, we can write the equation as, so we have got this part. Let me erase the remaining part so that we can make space for the solution. First, we'll write it in the vector form and we can get it back to the original form or Cartesian form, which is vector A plus, what is it? Lambda vector B. So position vector of a point is minus 2i plus 4j, then plus minus 5k. Okay, plus lambda times what do we have is 3i plus minus 5k, 5j, and plus 6k. Right, that is our equation. So which can be written as it's parallel to the given equation, we can write x minus 2 by 3 is equal to y plus 5 by 5. Yes, our points are right now y plus y minus 4 by plus 5 because it's minus 5. Yeah, so our A is 3, simple, B is minus 5, and C is equal to plus 6. In that case, we can directly written as x minus x1 by A, which is x plus 2. Yes, x plus 2 by, what is it? 3. Our equation will be simply x plus 2 by 3, which is equal to, what is it? Y minus 4 by minus 5, which is also equal to x z plus 5 by, what is our C we have here is, yes, 6. This could have been the equation of the our line. Let's see what is the solution they have given. Yes, see, x plus 2 by 3. If you carefully do that, y minus 4 by minus 5 and z plus 5 by 6. So we don't have to write it in the vector format. Without that also directly we can use, if you know directly ABC. As we know ABC, after rearranging the given equation, we know clearly what is the value of ABC. Using that, we can use the direct Cartesian format. Okay, yes. Let's go to the next question. Question number 2. The equation of a line are 5x minus 3 is equal to 15y plus 7 is equal to 3 minus 10z. Okay, so what are the direction cosines? So if you want direction cosines, first let's rearrange them. 5x minus 3 is equal to 15y plus 7 is equal to 3 minus 10 z, right? So I want to eliminate all the coordinates of this x, y, and z. So I'll divide this equation by 5. So what we get here is x minus 3 by 5. Okay, so this will become, if you divide the entire equation by 5, what we get? That's a thing. So x minus 3 by 5, which is 3y plus 7 by 5, which is equal to 3 by 5 minus 2z. Okay. So what we can do is we can take the values common. So let's see what they have done in this question. So they have taken the coordinates of x as it is by dividing the numerator and denominator by the same value. So to make it simple, let's do the same thing. So the given equation 5x minus 13, we can divide the and multiply by 5. So multiply by divide the numerator and denominator by 5. So 1 by 5 divide by 1 by 5. So what happens is x minus, this is 3, right? 3 by 5 divide by 1 by 5, which is also equal to, if we divide by 15, what we get is y minus of minus 7 by 15 divided by 1 by 15, yes, which is equal to 3 by 10 minus 3 by 10 plus z divided by minus 1 by 10. Yes. So now what happens is, these are the points and the direction cosines are here. So A is nothing but 1 by 5. B is nothing but 1 by 15. C is nothing but minus 1 by 10. So if you want direction cosine, what we can do is L, we have to find a square. First, we have to find a square plus b square plus c square whole root. Okay, so which will take a time. So I'll show you the solution directly. Please check this part. Okay, we can simplify this ratio further because we want a corresponding ratio only, right? If you want to find the corresponding ratio, we don't have to keep it in fraction. We can further multiply by the LCM and keep the value. So what we have got is 1 by 5, 1 by 15, and then minus 1 by 10. Multiply by the LCM. What is the LCM? Because we cannot have a fraction in the denominator. So the LCM will be into 30. So what we get is 6, comma 2, comma minus 3. So this is our direction ratio. A is equal to 6, B is equal to 2, and C is equal to minus 3. Because direction ratio is nothing but a proportional value of the given equation, right? So what is our square root? A square plus B square plus C square, which is 36 plus, this is going to be 49 and 7. Our L will be A by 7, which is 6 by 7. Our M will be 2 by 7. Our N will be minus 3 by 7. So that is our direction cosines. Yeah, 6 by 7, 2 by 7, and minus 3 by 7. So remember, it's a very important example to make us understand whenever it is in the format of, not in our format. So we have to rearrange them. Even though if you have got fractions, we can convert it to whole numbers by having a proportional value by multiplying by LCM of the denominator. Okay, yes. Let's go for the next question. Question number 3. What do we have? If the Cartesian equation of a line is this, first rearrange the line. X minus 3 by minus 5 is equal to y minus of minus 4 by 7 is equal to z minus 3 by, if you divide by 2, what we get is 8. Okay, yes. So write the vector equation of this line. So vector equation of the line A is given by what we have, x1 I plus y1 j plus z1 k, right? Plus lambda a1 I plus b1 k, b1j, and c1k. So what is a here? A is minus 5, b is equal to 7, c is equal to 8, and x1, y1, z1 are equal to minus 3, minus 4, and again uh, plus 3. Yes or no? Yeah. So this is not minus, this is plus 3. Yes. So in that case, what happens is our equation simply becomes uh, we are going to substitute this 3i plus minus 4j plus 3k. Entire thing lambda plus our a minus 5i plus 7j plus 8k. So this will be the vector equation of the given line. So let's see, do we have the same answer? Yeah, 3i minus 4j plus 3k plus lambda minus 5i plus 7j and 2k. Yes, what we have got is right.